Hello everyone, my name is Sahitya, working as Assistant Professor in EC Department, MLR Institute of Technology, Hyderabad. So we are discussing about the electronic devices and applications. In the previous videos, we discussed about the rectifiers, types of the rectifiers, operation of the full wave rectifier and operation of half wave rectifier, and also we have discussed about the parameters of the half wave rectifier. In this video, we have to go discuss about the parameters of the full wave rectifier. So today's content is in the full wave rectifiers, same as the half wave rectifiers, we have the DC value or average value, RMS value, ripple factor, efficiency, peak value, form factor and peak factor. So all these will be discussed in the today's topic, today's videos. So first DC value. In the last video, we already stated that the DC value is nothing but the mean value. So mean value is nothing but we have to calculate the average value. So coming to the full wave rectifier, what is the output of the full wave rectifier means it rectifies both positive half cycle and negative half cycle. So here the full wave rectifier can be designed. Full wave rectifier is a device which rectifies both positive half cycle and negative half cycle. So here the full wave rectifier is designed by using the two types. One is the with center tap and another one is the without center tap. For with center tap and without center tap, the output is same. So coming to this, here every cycle will be repeats for the 0 to 2 pi. Every cycle will be repeats for every 0 to pi radians. Every cycle will be repeats for every 0 to pi radians. Coming to the average value. So here in the average value, we have to calculate VDC and IDC. So how we calculate the VDC means the VDC is equal to 1 by time period. So the total time period of the cycle, then integration, we have to take the integration. Why we have to take the integration means here the signal is continuous signal V0 of t into dt. So here what is the V0 of t? V0 of t is equal to Vm sin omega t. Vm sin omega t, where t will be ranges from 0 to pi. Here the cycle will be repeats for every 0 to pi radians. So here Vm is nothing but the amplitude and omega is nothing but the frequency. Omega is nothing but frequency. So now calculate the VDC of the full wave rectifier. So what is the VDC of the full wave rectifier means? VDC is equal to what is the total time period for the full wave rectifier is pi radians. And here cycle will be varies from 0 to pi radians and V0 of t is equal to Vm sin omega t into dt. So for if you apply the integration, so here Vm is nothing but the constant, so you have to take it outside. Then integration of sin theta is nothing but minus cos omega t and the limits will be varies from 0 to pi. We know that Vm by pi into minus apply the limits. Cos of pi is nothing but minus 1 and minus lower limit cos of 0 is nothing but 1. So that is equal to Vm by pi into minus of minus 2. That is nothing but which is equal to 2 Vm by pi. 2 Vm by pi. This is the average value or DC value for the full wave rectifier. Coming to the IDC value. The next one is we have to calculate the IDC value. So IDC is equal to, we know that VDC by RL. So here the DC is calculated at the output point. So the output resistance is nothing but the load resistance. So IDC is equal to VDC by RL. So what is the VDC? We know that VDC is equal to 2 Vm by pi into RL. So Vm by RL is nothing but Im. 2 Im by pi. This is nothing but the IDC value. And this is nothing but the VDC value. Okay, this is about the average value, DC value or mean value. Next, RMS value. RMS value means root mean square value. So VRMS can be calculated as VRMS is equal to under root of mean value. So what is meant by the mean value? It is total time period 1 by time period of integral of 0 to t total time period integration Vm square mean square value V naught of square dt. So what is the V naught of t? So here every cycle will be repeats for, here every cycle is repeats for 0 to pi radians. The t will be varies from the 0 to pi radians. So now we have to apply here the total time period. What is the total time period? 1 by pi. And the duration of the cycle is 0 to pi. And what is the output for the 0 to pi? Vm square sine square omega t dt. So we know that what is the formula for the sine square theta? Sine square theta is equal to 1 minus cos 2 theta by 2. So that is equal to integration of, under root of 1 by pi. So Vm square is nothing but the constant value. We have to take it outside. Integral of 0 to pi. What is the formula for sine square theta? 1 minus cos 2 theta. 1 minus cos 2 omega theta by 2 omega theta by 2 into dt. That is equal to under root of Vm square by, here 2 is also the constant, by 2 pi. Integral of 1. Integral of 1 is nothing but t, and the limits will be ranges from 0 to pi, where cos 2 omega theta. Cos 2 omega theta means sine 2 omega theta by 2, and the limits will be ranges from 0 to pi. So that is equal to under root of Vm square by 2 pi, and the limits will be ranges from pi, and the lower limit is 0, minus sine 2 pi. Sine 2 pi, that is value is equal to 0, and sine 0 is equal to 0. So what is the value now here? Vm square by 2 pi into pi under root. Pi cancel. What is the value here? Vm square by root 2. Vm square by root 2. Vm by root 2. Vm by root 2. So the total RMS value, Vrms is equal to Vm by root 2. Vm by root 2. Okay. Now we have to calculate the IRMS value. So IRMS means Vrms by RL. So what is the Vrms value we get? Vm by root 2 into RL. Vm by RL is nothing but Im by root 2. That is nothing but IRMS value. This is about the RMS value. Next, ripple factor. Ripple factor means it is the ratio of AC component to DC component. AC component to the DC component. So here AC component tau is equal to VR RMS by VDC. So what is meant by the VR RMS AC component? AC component is equal to under root of V square RMS minus V square DC. So then tau is equal to under root of V square RMS minus V square DC by VDC. Now we have to apply the root and square for the denominator term. Then what is the equation? V square RMS by V square DC minus 1. So V square RMS. What is the value of V square RMS? V square RMS is nothing but Vm by 2, and IR VDC is equal to 2 Vm by pi. So V square RMS is nothing but Vm square by 2 by V square DC, Vm square by 4 pi minus 1. Vm square cancel. Then it is equal to 1 under root of 1 by 2 pi minus 1. So here the value is equal to 0.468. 0.468. So here comparing to the half-wave rectifier, in the half-wave rectifier what we get? For the half-wave rectifier, the ripple factor is 1.21. So comparing to the half-wave rectifier, the ripples will be reduces. The next, efficiency. Now, what is the output power? The output power is PDC. So PDC is equal to I square DC into RL. And what is the input power? Input power is taken at the AC power. Input power is nothing but AC power. So here the input power is dissipated. We have to calculate the input power dissipated at the diode plus input power, then AC power dissipated at the load. So here input power is nothing but the AC power. The AC power means we have to consider the both diode power and load power. So what is the diode power? Diode power is nothing but I square RMS. I square RMS, that is nothing but AC value. I square RMS into RF. Why it is RF means in the diode we having the forward resistance. So that's why we have to consider the forward resistance is RF. Next, load power is equal to, here also we are calculating the AC power. So AC power means the current is also the RMS current into, here the load is connected to the load resistance. Then what is the value of eta? Eta is equal to I square DC into RL by I square RMS into RF plus I square RMS into RL. Then it is equal to I square DC into RL by I square RMS. If you take the common term as I square RMS, then what is the value? RF plus RL. If you take the common as RL, then what is that value? I square RMS into RF. RL common, if you take the RL as common, then what is the value? RF by RL plus 1 into RL. RL cancel. Then what is the value here? That is equal to I square DC by I square RMS into RF by RL. We know that the forward resistance is very small. The forward resistance is very small. Then we have to neglect. The forward resistance is very small. So here we have to neglect that RF value. Then what is the efficiency? Eta value? Eta value is equal to I square DC by I square RMS. So what is the I square DC value? So I square DC value is, we already calculated DC. IDC value is 2 Im by pi. And I square RMS value is Im by 2. Im by pi whole square by, and I square RMS is nothing but Im by root 2 whole square. Now what is the value? 4 Im square by 4 Im square by pi square and Im square by 2. Im square cancel. Now what is the value here? 2 by pi square. So if you calculate that value, then it will get the 81.2 percentage. The percentage of efficiency is equal to the 81.2. The percentage of efficiency 2 by pi square. So that is equal to 81.2 percentage. So the efficiency is equal to the 81.2 percentage. Okay. Now comparing to the half-wave rectifiers. For the half-wave rectifier, what is the efficiency we get? For the half-wave rectifier, the percentage of efficiency is 40.6. Why? Because it rectifies only the one half cycle. Whereas coming to the full wave rectifiers, it rectifies both positive half cycle and negative half cycle. So that's why only it will get the 81.2%. Out of 100%, it gets the 81.2%. So in many applications where the rectifier will be used, where there we uses the full wave rectifier only. In the full wave rectifier, we can use either full wave rectifier with center tapped or full wave rectifier without center tapped. And the next, peak value. So what is meant by the peak value? Means the peak value is defined as the diode can withstand without destroying the junction, Whereas coming to the full wave rectifier, here the full wave rectifier is designed in two ways. The first one is full wave rectifier with center tap, and the second one is full wave rectifier without center tap. In the full wave rectifier with center tap, we are using the two diodes. When we are using the two diodes, one diode is connected in forward bias and another diode is connected in reverse bias. So during the positive half cycle, one diode is connected in forward bias and another diode is connected in reverse bias. So here that diode D2 will be stand at the voltage of Vm. The diode can be withstand up to the Vm. Whereas coming to the negative half cycle, one diode will be is conduction state and the another diode is in non-conduction state. So in this, it will also equal to the Vm. So the total peak value is equal to 2 Vm. Okay, this is about the peak value. And the next, form factor. Form factor means it is the ratio of RMS value to the average value. So RMS value means that is nothing but Vm by root 2. And what is the average value we get? 2 Vm by pi. Vm cancel and that is equal to the pi by root 2. So this is about the form factor. And the next, peak factor. So coming to the peak factor. So peak factor means it is the ratio of peak value to RMS value. So peak value is nothing but Vm and RMS value is, what is the RMS value here? Vm by root 2. Vm cancel, that is equal to the root 2. So this is about the peak factor. And next, so this is about the full wave rectifier parameters. In the last session, we discussed about the half wave rectifier parameters. In this session, we discussed about the full wave rectifier parameters. So here the full wave rectifier parameters are same for the with center tap and without center tap. Next, in the next session, we have to discuss about the filters. Why we have to go for the filters means, in the rectifier output is not a pure DC value. It contains some ripples. That ripples will be removed by using the filters. So here the filters are classified into two types. One is the capacitive filter and next one is the inductive filter. In the next session, we have to discuss about the filters. Okay, thank you.